Hi everyone, I'm going to give you your first example of translating on the coordinate plane. I am going to do this one right here, and I'm going to translate triangle ABC, and it looks like I'm going to translate it 5 units to the left and 2 units down. And I'm also going to label my axes. I'm surprised this graph didn't have it. Here's my x-axis. I know that that to go left, that's going to change the point on the x-axis because the x-axis goes left to right. And whatever the points are, their x value is going to be 5 less. And my 2 units down, that's going to be a shift on the y-axis. When this triangle gets moved 2 units down, all the points will be 2 points lower on y. And we'll look at that a little more closely later. With this first example, I'm just going to actually go in and count how many squares over and down I need to go and put each of those points in place. We won't worry about doing it from the rule first. We'll just do it point by point. I'll start with A. A right now is at 2, 4. So I'm going to say the pre-image, it was at 2, 4. And then I'm going to go left 1, 2, 3, 4, 5, and down 1, 2. That new point I'm going to label as A prime. It's got the little apostrophe mark. And then B, same thing, 1, 2, 3, 4, 5, to the left, down 2. That is B prime. And finally, C, I'm going to go 1, 2, 3, 4, 5, left, 1, 2, down. That's C prime. Oops, I didn't keep noting my points. Then I can just take a ruler if I want to make it look really nice and connect that. And when you connect the points, you should have an image made from your pre-image that is congruent, absolutely congruent, the same size, same shape as that original image. That's the pre-image. So mine isn't totally beautiful, but these should be perfectly congruent because every single point moved the same direction, 5 left, 2 down. And so this triangle should be exactly like this one. So I'm going to go ahead and get all my points for my pre-image. B is at 6, 7. And C is at 7, 3. Now my image, my copy, my x is at 1, 2, negative 3, positive 2. My B prime is at 1, 5. And my C is at 2, 1. Now, I just manually went and counted all the points over on the graph. But I could also use some math to figure out where all of those points would go. So my pre-image had the coordinates x, y, x, y, x, y, x, y. All of my image coordinates were to the left 5. And every time I went to the left, I was going down. So I could say they were whatever x was and 5 to the left, minus 5, moving left on the x-axis. And y went down 2. So that would be y minus 2. And you can see mathematically that if I take 2, I subtract 5, I get 3. I take 4 minus 2, and I get 2. Take my x, 6, take away 5, that's 1. 7, take away 2, that's 5. Etc., etc. 7 minus 5 is 2. 3 minus 2 is 1. So when they said 5 units left, 2 units down, that's x minus 5, going lower, 5, y minus 2. So look for any patterns and describe what happened after the x and y values in each ordered pair. The x values went down by 5, and the y values went down by 2. And so our rule is you take x, y, and to make the copy, to make the image, you have to do x minus 5, y minus 2. And that's the algebraic rule, the code for that translation. So again, I went left 5, down 2, x minus 5, y minus 2. I had a pre-image, I made an image, and I used primes on all of my points to indicate that that was the image, that was the copy. And it should be perfectly congruent because I moved every single point in the same direction. It's just like I took that shape and I slid it. I slid it left and down. And that's your first example.